Questions 16, 17 and 18. Which of these substances does not contribute to the greenhouse effect? So the greenhouse effect is where infrared light from the sun is expected to reflect off the Earth's surface and go back out into space. However, sometimes the gases absorb the infrared light and prevent it then from reflecting back out into outer space. They warm up and contribute towards the greenhouse effect. Which gases will do this? Unburned hydrocarbons such as methane, yes, they will contribute to the greenhouse effect, so the bonds within them will absorb infrared light. Carbon dioxide will do too, so carbon dioxide produced during the complete combustion of hydrocarbons in a plentiful supply of oxygen. Water vapour will do too, so that's a common mistake to think that water vapour doesn't contribute towards the greenhouse effect, but the hydrogen to oxygen bonds in water vapour actually absorb infrared light as well. Nitrogen, 79% of the Earth's atmosphere is nitrogen. It's an inert gas, an unreactive gas that won't absorb infrared light. The answer is D, nitrogen. This is a tricky kind of question because they've done a mechanism here in a way that I wouldn't normally do it. So the way that I would react this is that you've got ammonia with a lone pair of electrons acting as a nucleophile, a lone pair donor attacking the C center. That's perfectly acceptable with a delta plus on the C because the CBr is a polar bond. The Br is electronegative and draws electrons towards itself, so this will have a delta plus charge on it, and the Br would have a delta minus charge on it. Perfectly acceptable at NH3. A nucleophile will attack a delta plus center, and perfectly acceptable then that the Br will accept the electrons from the double bond, from the single bond rather, the electrons from the bond onto itself and form Br minus with a lone pair of electrons. Perfectly acceptable, both of those arrows. What I would then normally do is I would have the Br coming off being substituted and the NH3 bonding to the C, and there'd be a plus on the N, and one of the H's then would break off with the electrons from the bond going onto the N plus and forming an NH2 group on here. That's the way that I would do that mechanism, that nucleophilic substitution mechanism. They've done it slightly differently here. They've got another ammonia with a lone pair of electrons accepting an H plus that will form NH4 plus an ammonium ion. Then the problem, and that's perfectly acceptable, the problem then is that this electron pair from here should actually, from the NH bond, actually go onto the N plus and cancel out the N plus. So that should be the way that would work. Arrow number 4 is incorrect. A tricky question there because you've got a mechanism that's overly complicated. Which statement about the reaction is not correct? Ethylamine is a primary amine, so you've got CH3, CH2, and it's going to form NH2 on here. The NH2, the N is bonded to one carbon. The N bonded to one carbon is a primary amine. The mechanism is nucleophilic substitution. Yes, it is. So this NH3 is going to attack the C plus and substitute for the Br. And this is a nucleophile, an electron pair donor, perfectly acceptable. Using an excess of bromoethane will stop further reaction to form a mixture of amine products. Now it actually won't, because when you form CH3, CH2, NH2, ethylamine, the N of the ethylamine will have a lone pair of electrons, and so it will react again to form diethylamine, and then react again to form triethylamine, and then react again to form a quaternary ammonium salt. So the fact that you've got excess bromoethane will mean that the ends of the ethylamine, the diethylamine and the triethylamine will actually carry on reacting. So C is incorrect. Ammonium bromide, that's NH4Br minus. Bromide is a Br minus ion, and ammonium is an NH4 plus ion. Is an ionic compound. Yes, it's going to form an ionic solid, so D is correct. So C is the incorrect answer.